The walls were 30 feet thick at the base, 4 bastions, 25 acres, built to stop an army that never attacked. On August 15, 1820, Lieutenant Colonel Elias Walker Durnford stood on Cap Diamant overlooking the St. Lawrence River, marking positions for the first stone placements of the Citadel of Quebec. The British military had given him a singular mandate: build a fortress that could withstand sustained artillery bombardment from American forces. Not just resist attack, survive it indefinitely. Mouts Durnford had studied European fortification design under Dutch and French military engineers. He understood siege warfare mathematics. He knew what happened to walls during sustained cannonball impact. The Americans had demonstrated improved artillery range during the War of 1812. Existing fortifications around Quebec were obsolete. Timber palisades would splinter. Thin masonry would collapse inward. The new fortress needed walls thick enough to absorb direct hits without structural failure, and he specified stone and earth-filled casemate walls 30 feet thick at the base, tapering to 20 feet at the top. Engineers in London reviewed the plans. They questioned the dimensions. 20 feet would suffice against known artillery. Durnford's response was documented in military correspondence. The walls weren't designed for known artillery. They were designed for artillery that would exist 50 years hence. Construction began September 1820. Workers quarried limestone from nearby Beauport. Each block required 4 days of shear cutting, shaping, and surface dressing. The blocks weren't uniform. Dimensions varied from 3 to 6 feet length, 2 to 4 feet width. Thickness determined by wall position. Foundation blocks were largest, weighing 4 to 6 tons each. The construction method was deliberate. Outer limestone face, interior earth and rubble fill, inner limestone face. The fill wasn't random. Workers placed crushed stone in 6-inch layers, compacted each layer, added lime mortar binding. The 3-layer system created walls designed for shot absorption rather than deflection. A cannonball hitting the outer face would penetrate the limestone, expend energy in the earth fill, and stop before reaching the inner face. Foundation work consumed 3 years at some sections. Workers excavated to bedrock on Cap Diamant, 15 to 20 feet below planned grade. Where bedrock sat deeper, they drove timber piles first, 12 to 18 inches diameter, spaced every 4 feet. As the fortress sat on granite bedrock or timber foundations extending to refusal depth. Durnford designed the citadel as a star fort, following Vauban's principles adapted for North American terrain. 4 diamond-shaped bastions projected from the main walls, each bastion providing overlapping fields of fire. The geometry eliminated dead ground. Any point outside the walls could be targeted from at least 2 positions. The design was 150 years old. The wall thickness was unprecedented for peacetime construction. Labor force peaked at 850 workers in 1823. But most were French-Canadian stonemasons and laborers. Pay was 5 shillings per day for skilled masons, 2 shillings 6 pence for laborers. Workers lived in temporary barracks on the construction site. Winter halted work November through March. Temperatures at Quebec reached -25 Celsius. Mortar wouldn't cure. Stone became brittle. By 1825, the main defensive walls stood complete. The structure had consumed 145,000 cubic yards of cut stone. Workers had placed approximately 58,000 individual limestone blocks. Each block was inspected before placement. Cracks wider than 1/8 inch disqualified stones. Surface irregularities beyond half-inch tolerance disqualified stones. Rejected blocks were used for fill or secondary structures. The casemates were built into the wall thickness. Vaulted chambers, 12 feet wide, 20 feet deep, extending through the 30-foot wall thickness. These chambers served as barracks, powder magazines, and storage. The vaulted ceilings distributed roof loads across the wall mass rather than concentrating stress at edges. Each casemate could withstand the collapse of the chamber above it. Construction continued through 1831. Total cost, £384,000 sterling. The British government had budgeted £280,000. The overrun triggered parliamentary inquiry. Durnford provided technical justification. The walls were built to survive 6-month siege by forces equipped with 24-pound siege guns firing heated shot. That specification required 30-foot thickness. The inquiry accepted the explanation, but suspended Durnford from further major projects. As the citadel was completed, but never fully armed, the British military installed 72 artillery pieces, mostly 18-pound and 24-pound guns. The fortress was designed to mount 168 guns. The full armament was never purchased. Military doctrine changed. Steam-powered ironclad warships made coastal fortifications less critical. Railway construction allowed rapid troop movement, reducing the need for permanent garrison fortresses. The American attack never materialized. Relations between Britain and the United States normalized through the 1830s and 1840s. Of the Oregon Treaty of 1846 and the Reciprocity Treaty of 1854 reduced military tensions. The citadel's strategic purpose diminished before the structure was fully operational. The walls stood unused. No siege, no bombardment, no test of Durnford's engineering calculations. The 30-foot walls, built to absorb cannonball impacts instead, served as administrative buildings and troop housing. But the fortress endured. Quebec winters tested the stonework annually. Freeze-thaw cycles occurred 180 times between 1831 and 2024. Modern limestone structures show significant deterioration after 50 cycles without modern sealants. The citadel's limestone walls show minimal degradation. The earth fill system provides thermal mass, moderating temperature cycles in the wall core. The outer limestone face weathers, but the structural wall behind remains stable. The British garrison remained until 1871. Canadian forces assumed control after Confederation. The fortress transitioned to training facility and ceremonial post. Military use continued, but threat assessment changed. Our artillery improved beyond anything Durnford imagined. Rifled cannons firing explosive shells made star forts obsolete by 1860. The thick walls that would have stopped solid-shot cannonballs couldn't resist explosive ordnance. The citadel never fired shots in anger. The walls never faced the siege they were built to survive. Durnford died in 1850, 19 years after completion, having built a fortress that was obsolete before it was finished. Modern structural surveys occur every decade. Engineers measure wall settlement, stone displacement, the mortar degradation. The 1995 survey documented findings after 175 years of service. Wall settlement, 2 to 4 inches total, well within foundation design tolerances. Stone displacement, minimal, concentrated in areas exposed to prevailing winds. Mortar degradation, 15 to 20% of exposed joints require repointing. The walls were overbuilt by factors difficult to calculate precisely. Modern fortification engineering suggests 15-foot walls would suffice for the artillery threat Durnford faced. He built 30-foot walls, on double thickness. The safety margin was either paranoia or prescience, depending on perspective. The casemate vaulting remains structurally sound. The vaults support their original design loads, plus 190 years of accumulated roof structure weight. No reinforcement has been added. The limestone and rubble fill combination performs as designed. Canadian forces still occupy the Citadel. It functions as the home of the Royal 22nd Regiment. Ceremonial duties occur daily during tourist season. The fortress serves as museum and active military facility simultaneously. Of the 30-foot walls require maintenance, repointing, drainage clearing, vegetation removal, but no structural intervention. A military engineer reviewing Durnford's specifications in 2015 called them remarkable. 30-foot walls for threat assessment requiring 15 feet maximum. Foundations to bedrock where 10-foot depth would suffice. Casemate vaulting designed for loads 3 times expected maximums. The assessment concluded this fortress was not built to survive a siege. It was built to survive forever. And the walls still stand. The limestone blocks placed in 1820 still carry structural loads. No rebuilds, no reinforcement. The mortar has been replaced in sections. The stone has not. Lieutenant Colonel Elias Walker Durnford built the Citadel of Quebec to stop an invasion that never came. He died believing the project had been excessive, criticized for building walls twice as thick as required. The British Empire that commissioned it dissolved. The military technology it was designed to resist became obsolete. The strategic threat evaporated. The stone remains. The walls endure. Quiet monuments to an engineer who chose permanence over practicality.